Hello everyone, in today's video I'm going to show you how to make a bouncing platform so you can make your character jump this way from one platform to another. So let's not waste time and get started. The first thing I'll do is to create a game scene. Under the game scene we'll put the background, the character and the platforms. And let's go ahead and save it. The next thing I'm going to do is to add a background, so it will be a little bit more interesting when we jump from one platform to another and we see the actual progress. Now I'm going to use a simple background I've prepared in advance. If you're looking to make a game with endless number of platforms, you may want to look into something called looping background or scrolling background, where you will basically not reach the end of the background. And what I'm doing right now is just adjusting the background, so when we'll start and play the scene, we can see the background from the beginning. And let's play the scene and see how it looks like. Okay, looks good, we can proceed next. Now we're going to create the platforms on which the character will jump. And for the platform I'm going to use an area 2D type of node. The reason is because we don't need the platform to move in any way, we just need to use it for the collision with the character and make the character jump when it collides with it. Now I'm going to set the texture for the sprite 2D. And then afterwards I can basically go ahead and define the collision parameter. Don't worry about not making it very accurate the first time, you can always adjust after you're done. And now that our platform is ready, we have the sprite and the collision, we can go ahead and save it as a scene. And now I want to show you how you can take this one platform and create many of those. And for that we're going to use code. It's not efficient to go and manually start adding many platforms, so we'll definitely prefer to use code for that purpose. But before we go ahead and do that, let's explain how it's going to work. So we're going to create a loop, and in that loop, every iteration we're going to create 3 platforms in 3 different X positions. This loop will keep iterating for a limited number of iterations that we'll define. And between every 2 platforms, we're going to have a fixed difference of 200 on the y-axis. We're going to start from a positive y value, and eventually it will become negative because we go up. And that's basically what we're going to code. So let's go ahead and do that. Let's start by cleaning up the code. The only function we'll need right now is ready. And what we'll do is to create a dedicated function for creating the platforms. Now remember, in that function we're going to create a loop, and in that loop every iteration will create the platforms. Let's define the variables for y position and x positions. We'll later put a value for them. And once we have the variables defined, we're going to start our loop. Now I'm going to have 40 iterations, but you can use any other number here. And every iteration we want to create the platform on different x position. And since we're going to have 3 positions on the x-axis, we're going to use each iteration a different number. Next, let's create the instance of the platform. And for that we'll also have to define the platform scene. So I'm simply loading the scene using this syntax. And now I can finish up the definition of the instance. Let's go ahead and add the X positions. And remember, only one item will be used from that array every iteration. Next, we'll go ahead and add the platform to our game scene. And until now, we didn't actually set the position of the platform, so let's go ahead and do that. And it may be confusing why it's positive, but as you can see, we're starting below 0, and below 0 it's a positive y. Now what left to do is to make sure that every iteration we also go up on the y position. This way we'll create platforms until the end of the background. Now the syntax I'm using here is the same as writing this. It's simply much shorter and common version of doing so. And right now it seems that we can't run our code. Let's see why. Okay, we need to indent it a little bit so it's under the function. Now it should be good. Let's run it and see how it looks like. And it looks like we still have an issue, something about our position. Okay, yeah, so the reason seems to be that we didn't use a vector 2 for the position, so let's go ahead and fix that. And now if we run it, it should look fine. Okay, good. We're creating multiple platforms in different X and Y positions. You can't see it right now, but it goes until the top, you'll see it when we'll play the game. Okay, now it's time for us to go ahead and create a character. Let's use character body 2D for that. And we're going to use animation sprite 2D because eventually we'll have different sprites for the character. We'll have one sprite for idle and one sprite when the character jumps. In addition to that, we need collision shape in order to detect collision between the character and the platform when it jumps. And let's go ahead and define a sprite frame. As we said, the first one is going to be idle, so whenever the character doesn't jump, and the second one is for jumping. The definition itself is very simple. We're just going to drag the sprite for each animation. And what is left to do is to also define the collision parameter. We need to do it only once, so no need to do it for every animation. And we'll use a simple rectangle. The important part here is to make sure that it covers it from the bottom of the feet. And once we are done with defining the collision shape, we can go ahead and save the scene. Okay, great. Now we can go ahead and add our player to the game scene. And you're already familiar with the steps. Basically, it's first of all loading the player scene and then creating an instance out of it. Once done, you can also move the code to a dedicated function. There is no reason to put it directly under ready. So let's go ahead and add the create player function. And once defined, let's make sure to also call it from the ready function. Now let's run it to see how it looks like. And you notice we have a problem. First of all, it's a little bit big, and also it's behind the platform and not in front of it. The fix for it is quite easy. You simply adjust the z-index to b1. The default is 0. And that, as you can see, solved it. But I also want to reduce the size of the player because it's quite big right now. I'm just going to first reduce the size of the sprite and then also the collision parameter. Okay, let's see how it looks like. Looks much better, much smaller, and we know it's also in front of the platform. What we'll do next is to go ahead and create the script for the character. And the first thing we'll do in the script is to mark the class as a player. It will be much easier for us to reference it later. What we want to do now is to add some gravity for the character. And to add gravity, we want to increase the velocity, specifically on the y positive direction. So let's go ahead and add it. And I will set gravity to 14, but you can use any other value that you prefer. Once we added the gravity, the last thing to do is to actually move the character, and we'll do it with the move and slide function. Now let's have a look on how it looks like. Looks good. Now I want to show you how it looks like when we decrease the gravity. As you can see, it's almost floating. Now what I want to do next is to switch between the animations, and to be more precise, I want the player to have the jump animation when it jumps and idle in any other situation. The logic will be to check the y velocity, so to check if it's positive or negative. And let me show you what exactly do I mean. So let's go to the character. So whenever the y is decreasing, it means our player jumps, and whenever the y is increasing, it means our player falls. So let's go ahead and implement it. So whenever our character falls, we want to go ahead and set the animation to idle. And first we'll also check that it's not idle already. And if it's not idle already, then we'll set it to idle. And we'll do the same for jump. So whenever the velocity is negative, we'll go ahead and set it to jump. Now at this point it won't work because we don't have the player animation defined. So let's go ahead and define the player animation by referencing the animated sprite 2D. And if we run it right now as it is, it won't do much because we only fall. So let's go ahead and define the jump. Now in order to jump, we want to make sure that the player goes in the negative direction of the y-axis. So we're going to set a negative value on the y velocity. I'm going to set it to the value of -600. Now this alone is not enough. We need to make sure that something triggers the jump. And we want to trigger the jump every time the player collides with the platform. So let's go ahead and add the script for the platform. And the idea will be that every time we detect a collision from the platform side, so anytime something enters the platform, we'll go ahead and trigger the jump function that we just added. In order to do that, we'll use something called signals. So a signal will tell us every time something enters the platform. Now instead of writing it, let me show you how you can do it. You go here and we'll use body entered. So let's go ahead and add it. And this function will be triggered every time something will enter the platform body. Every time this something will be a player, we'll go ahead and trigger the jump function. We also need to make sure that we trigger it only when the player is falling. So that means the velocity is positive. Okay, we're finally ready to run and see how it looks like. Okay, great. You can see that it works. Every time we jump, we change to the jump animation. and every time it falls, it goes back to the idle animation. We now have a bouncing platform. What we want to do next is to make sure that we can move our player from side to side. So let's add a simple conditional to check if the left or the right arrow were pressed. Let's simply copy paste it, so it will be the same for the right arrow. And once we know if the left or the right arrow was pressed, then we can go ahead and capture it in the direction variable. Once we have the direction, we can go ahead and change the velocity, but this time the velocity on the x-axis, because we want to move our player from side to side and not up or down. Now the velocity is taking the direction and multiplying it by the speed that we'll define. I'm going to set the speed to 280, but again, you can set it to any value that you prefer. Now let's give it a test and see how it works. Great, we can move our player from side to side, but as you can see, the camera doesn't follow. So let's go ahead and fix that. To create a camera that will follow, we'll use the camera 2D type of node. And let's immediately also create a script for it. And the first thing we'll do after creating the script is to get the size of the view. So let's go ahead and add the ready function. And once the camera is ready, let's get the viewport size. We want to get the viewport size in order to set the camera exactly in the center, and more specifically on the x-axis. Now let's go ahead and save it. And in order for it to work, let's make sure that we define the viewport size variable. Now we can go ahead and move to our game scene and add the camera. So same as we've done with the platform scene and the player scene, we're going to add a variable for the camera scene. And again, we don't want to put all of the logic in the ready function, so we're going to create a dedicated create camera function. Now you should know that this function is going to be different because it's going to get the player. Eventually we want our camera to follow the player. And for that we need to change our create player function to return the player. And now let's go ahead and implement the create camera function. And the first thing to do is to create an instance of the camera. And once we've created an instance of the camera, we want to set up the camera so it follows the player. This is where we're going to use the player that we passed to the function. And as always, we want to make sure that we add the camera to the game scene. Now let's make sure that we define properly the variables for the player and the camera. And the only thing left to do here is to pass the player to the create camera function. Okay, now let's get back to our camera scene and let's implement the setup camera function. So remember, it gets a player, so let's add it to the signature of the function. And let's also validate that we have an actual player instance and it's not a null. And then we can set player variable to what was passed to the function. Let's add a variable for this player. And at this point we just did all the setup that needed, but our camera still doesn't follow the player. So let's edit physics process and make sure that every frame our camera position is set to the player position. And make sure that you add some offset because we want to see a little bit more down than the player itself. Let me show you for a second how it looks like without an offset. As you can see, not optimal. And also see what happens when we fall. Yeah, we need to limit it as well. So this is the offset. As you can see, now it looks much better. And now let's also make sure that we limit the camera to the bottom. So this is going to happen in the process function. And I'm just going to set it to 650 because this is where we started our background. And now when I run it, you will notice that I can no longer see below the background, which is great. So this is it for this video. We made a bouncing platform. Our player jumps from one platform to another. We have set up a camera that will follow it. And I hope you enjoyed this video and you learned something new. See you on the next one.